Hey everyone, and welcome in my session here at Azure Back to School campaign, organized by our fellow Azure enthusiast, Dwayne Netwick. My session is going to cover an introduction to Azure DevOps, and more specifically, Azure DevOps pipelines to bring you some cloud magic. In this session, I'm going to walk you through I would say almost a day-to-day approach to managing source code, and from there how Azure DevOps can help you in the process. Because if you look at how you as an IT pro or maybe developer, you're going to work with source code. Could be application source code, but it could also be Azure templates, Terraform templates, or anything else like PowerShell scripts that you want to manage. It's not always that easy to centralize it, to share code with your colleagues. So that's the switch between source control and project management, in my opinion. And from there, I'm going to walk you through how Azure DevOps can help you in running a validation, the pre-flight stage if you want, which means that you're going to run a validation optimization on the pipelines before you're actually going to push the button and deploy it. And then obviously the core idea about pipelines is optimizing your deployment, and I'll show you that in a couple of demos as well. Now, we don't really have Q&A in this recorded session, but obviously feel free to reach out whenever you got any questions here. So my name is Peter Ditender. I'm based out of Belgium, and before the COVID situation was somehow locking down the whole world, I was traveling about 95% of my time. Now, thanks to my fellow Azure friends here in Belgium, they asked me to join the MC2MC user group with a focus on Azure and Office 365 primarily. In my day-to-day job, outside of my community work, I'm an Azure Business Program Manager within Microsoft, and specifically working as an Azure technical trainer, providing Azure readiness workshops to larger customers and partners all over the world, but virtually working from home. Before I joined Microsoft last year, I was an Azure MVP for 5 years, and in the little bit of free time that I have, I keep myself busy still with Azure, writing technical books and overall white papers. So again, feel free to reach out, stay in touch whenever you want, and I'm ready to jump in the main topic. So just to refresh your memory a little bit, and obviously this is what you most probably do on a day-to-day basis. So without anything DevOps related, this is how we work today. So around source control or version control, in a more traditional manual way, it means that you're going to create your deployment script like PowerShell, ARM templates, Terraform templates, or even full web applications, and you probably keep track of the versions yourself. So you're going to create different folders. Maybe you're going to store them in OneDrive, you're going to store them in Dropbox, or maybe using SharePoint, why not? And you're going to share them around with your colleagues to get some validation, maybe having some updates. And before you know, you got 300 different versions in 700 locations all over your computer. And that's somehow still doable as long as you're just working by yourself. Because in the end, it's your machine. You hopefully remember where you store your files. But even there, it could become quite messy. But taking it one step further, when you need to share code with your colleagues, or maybe even with customers or partners outside of your closed network. So what we need is some kind of optimized project management, where obviously today we already have the tools, but they're not always built to do that. So we're sharing code around using Outlook, sharing snippets on Teams. You might probably use something like GitHub or any other storage location. And in some larger organizations, obviously we see some tools like Microsoft Project, where you can obviously do end-to-end project management, but it's not always that easy to validate the code in between the projects, creating new items and such, or why not keeping track of all the project tasks in a manual way. And next to that, once you have your project items in place, you still need to update and track your code changes. And it's all done pretty manually. Or moving to the traditional way on how to run code validation. So I know that in PowerShell, RM templates, Terraform, you can use something like a what if statement that's going to validate the code, but in the end, it's mainly running the validation right before the deployment. So we can't really call that optimized. Or if you're using Visual Studio Code, or some other smart development environment, you typically gonna right-click Publish before you can validate that it's actually gonna work fine. And if you have multiple tests to be run, you also need to create multiple test environments. And in the end, it's all quite challenging. So enough about the traditional way, and let's jump to a couple of highlights and demos where I'm going to walk you through the scenario where Azure DevOps can help you in optimizing almost each and every of those project topics. Starting with source and version control. So one interesting feature or service within Azure DevOps is called Azure DevOps repos. And Azure DevOps repos by itself is a Git compatible source control system. So if you're a little bit familiar with the public GitHub, you might know that it's quite easy to check in code, making changes, committing changes, branching, where you can create different versions. Like within a team, each and every developer or sysadmin could work on in his or her own branch, and from there merging all the changes, working with pull requests. So unfortunately, we don't really have a lot of time in this session to drill down on all those characteristics, but the baseline is that from here, you're going to start working on your project. You start working on your source code files, which again can be template files, PowerShell scripts, or full application source code. And from there, you're going to commit the changes and sharing it with the rest of your team. And technically, you don't even have to share it because you're all working on the same source control Azure DevOps repos. So let me show you that in a first quick demo, how it works. Now, before diving into DevOps, let me show you how you can actually get started with DevOps. So it starts with an Azure subscription. Now, technically, you don't have to use an Azure subscription first, but the assumption is that you're going to use Azure DevOps to most probably deploy resources in Azure. Now, just to be sure, Azure DevOps, although it has the name Azure in the terminology and the definition, is not limited to publishing anything on an Azure platform. So you can perfectly use Azure DevOps to publish source code, applications, databases, templates against an on-prem environment, AWS environment, Google Cloud environment, but I'm going to walk you through some Azure demos. So out of your Azure subscription, you search for Azure DevOps, where we have two different flavors. DevOps Starter, that's allowing you to almost immediately publish a web app using different development languages in a DevOps approach. That's not what I'm going to cover, but I'm going to switch to DevOps organizations. So from here, the first step is creating a new DevOps organization. If you already have multiple ones, you could obviously reuse those as well. And from here, you can create a new one, click continue, you need to re-authenticate, and from there, your DevOps organization is ready. And that's what brings you up here. So I obviously already have one, where from here, I can work on a project. Now, what is a project? It's literally something that combines source control, pipelines, project management, release all together, where you're going to invite your team members. Internal Azure Active Directory based, public, which means that anyone on the internet could help you in the project, or private, where you selectively gonna invite team members. So this would be the back to school project, where out of the box, Azure DevOps is gonna provide the full integration with all the different services. So back to our Azure repos, where we have an empty project for now, and we obviously want to add some code into it. So what we're going to do is creating a clone. And again, if you're familiar with the more traditional GitHub, you probably recognize the terminology here. So what we can do is cloning in our preferred editor or development environment, where I'm going to use Visual Studio Code. So it's going to ask you, where do you want to store the repository? And just to keep it easy, let's store it on my local drive and call this the back to school. So it's cloning the repository. And from here, we can start working on source files. So you would create some new files here. Now, just to speed it up a little bit, let's grab a couple of sample templates, like ARM templates, to deploy some Azure Magic. Where, as you can see before, I was using GitHub to store those files, and we're now slightly migrating away from that and pushing them into the Back to School project. So that's a little bit of housekeeping if you want. Now, without doing anything, it's all Azure DevOps repos integration together with Git in the backend. You can see here that my source control is already in action. So it recognizes that I do have 3 new files. Where now it's all local on my machine. So I'm going to initialize it and committing the changes. So the changes are gone, which means that my source control has recognized the changes. So let's go back to Azure repos, check on the files, and nothing's really happening. So what's going on? Don't worry too much about it. There's actually a little safety net built into the process where, although I already checked in all the changes on my local machine, technically they're not synchronized back to Azure repos. Now, to fix that, we're going to click on this little cloud here and publishing changes. Now you can dive into Visual Studio Code source control settings and actually activating that you always want to sync. But imagine that you make some changes, and when you commit the changes, you go like, damn it, I made a mistake. You can easily go back before it's already synchronized back to Azure repos. So let's validate here what happened. So in the meantime, my source files are also cloned into Azure DevOps repos, and I can see my initialize. So we're going to move on with the process and back to the files, and why not making some changes. So I don't like the PDT lab admin. I'm going to use PDT admin, and let's change the password because it's all community here. It's user group, so obviously it's not that good to show you my password. So we're gonna quickly change this and saving the changes. Whew, that was close. I almost wondered that anyone could see my passwords. So source control is, again, once more detecting it, and this is a new commit where I'm gonna call PDT changed the password and committing the changes again. Nice. Down here, it's going to highlight there's nothing changed on the server, but imagine that you work together with a team. It would obviously recognize that as well. And there is one change waiting to be uploaded. So pushing it once more, waiting for the synchronization. It's in full sync, which means that up here, we can see another change. Even interesting here is that the process is keeping track of the user account you're using. So in my commit message, PDT isn't even necessary anymore because my developer lead can actually validate that I made the changes. Next to that, you can easily pinpoint what changes have been made. So I can see that before it was lab admin and some password, and now it's a new PDT admin account and obviously another password. So that's in short the source control magic, allowing you to integrate your ARM templates, Terraform templates, PowerShell scripts, or full application source code and storing it centralized in Azure DevOps repos. Nice. So from here, imagine that I'm not working just in my own single person team, but I'm going to expand this to the rest of my project team. Internal colleagues, external colleagues, partners, doesn't really matter. So you start with inviting them into your project management. They don't become part of the full Azure DevOps organization, but it's really individual per project that you can define it. From there, you can start working in an agile Scrum project development, project management approach. And that's where we're going to work with work items, creating boards, creating sprints, which is like a deadline somewhere in the future. And any work item like a task that is not getting complete by the sprint deadline will be moved to a backlog. So even if you're not really into Scrum or Agile or any other development process, project management, you don't really need to become an expert to actually start using it. So I'm going to switch to another project just to show you how easy you can switch from one to the other, where we can use boards. And what you can see here is a listing of all the different work items that our project team is working on. So this could be adding new features. This could also be defining infrastructure tasks, like you need to resize Azure virtual machines. And from there, you're going to execute a task, you close it, or you can define that it's a work in progress. That's what you manage from the boards. You might be familiar with Kanban as one of the methodologies that you can use here, which means that one of my outstanding tasks, or it could also be a bug getting reported from one of our users or developers, that for now it's in a design phase. And for each and any of these tasks, we can assign them to our technical team. We can change the severity of the bug, and we can define that it's becoming a work in progress. So all this is just optimizing, managing your overall project process. From here on the side, you could also create some nice looking dashboards, like for management or developer team leads, sysadmin leads. They can actually get a nice view on what's happening with your projects. Even better, once we switch to pipelines, where we're going to run a build process like compiling code, validating template files and such, you could also integrate those with the work items. That you have an ongoing work item. Let's say I'm working on fixing a bug, which means I'm going to test my new code, validating that everything is working as it should be before we're going to move it into a running state. And I could integrate this back to my work items to again make sure that my project lead can follow up on what I'm working. So the build stage, or the CI part in the pipelines, is where you're going to compile a step-by-step task-based sequence, allowing you to pre-compile your source code. So I'm going to use one web application to just show you, because there's not too much to be validated in Azure templates, and walking you through the process. Now, in short, the way it works is that instead of compiling it on your local machine, you're going to push out the code to an Azure DevOps build agent. So those are pre-configured hosted virtual machines in Azure, running in the Azure DevOps organization and not visible in your Azure subscription virtual machines. So it's like free build servers that Azure is giving you. Now, important, the free build servers is depending a little bit on the project definition. So there are a couple of details, and I would encourage you to check on the pricing details for Azure DevOps. But technically, as an organization, you have three different scenarios. The first one is, I would say, community-minded, where you can run each and every project as long as you define it as public to compile source code, and you don't have to pay anything for it. So there's no Azure consumption. As a organization, you could license Azure DevOps for each and every of your DevOps team members, which comes with a specific cost per user per month. And next to that, you could also pay for additional pipelines, allowing you to run multiple tasks simultaneously. If you don't like the hosted build agents out of Azure, you could also create your own build servers. So this could be interesting for legacy software that's maybe not compatible anymore with the latest and greatest version from Azure build agents, or maybe from a customization perspective, you might need to inject specific frameworks that, again, are not running anymore on the build agents that you have out of the Azure DevOps concept. Next to that, it's not just Windows build servers, so you get access to Windows machines, Linux machines, and macOS, allowing you to run about any code validation you want. So I have my application here. It's an open source web shop where I have some ARM templates and my application source code. So if you're a developer, you might recognize some .NET integration here. So a couple of app settings JSON files, my C# JSON files, and the actual source code. So that's my application. So let's create a new pipeline. And worst case, I can go back to some pipeline that I already have, where it's going to walk us through a quite basic but powerful scenario in just a couple of easy steps. So the first question is, where is your source code? Now we know that for here, it's in Azure repos, but it's not limited to Azure repos. So you can use Azure DevOps to integrate with GitHub, GitHub Enterprise on-prem, or any other Git compatible scenario. We select our repo, and based on that, we can define what kind of application am I using. So is it .NET, is it Java, is it Node, or anything else? So my application is a .NET one, and just like that, it's going to create a pipeline. If you're a little bit familiar with Kubernetes, you might be familiar with YAML already. So it's technically some kind of scripting file in which you're going to define the different steps that need to happen. So from here, I'm going to run it, saving it, and this is the pipeline demo YAML. Now the nice thing in using YAML is that the source code itself is integrating with the pipeline. So instead of just running infrastructure as code, you can now also move to deployment or configuration as code. The job is kicking off. It's in a queued state because I'm using the free version. And it means that every now and then it could take a couple of seconds, worst case a few minutes, before the job is kicking off. Now, let's go back and walk you through another scenario. Well, this is running anyway and creating a new pipeline, but this time relying on the more traditional pipeline creation that's now called Classic Editor. If you have some background as a developer in Visual Studio Team Services, or even before, longer time ago, Team Foundation Server, you might recognize what I mean by the Classic Editor. So the process is about similar. So we start with Azure repos, but this time we can select from pre-configured templates in a graphical interface what we want to achieve. So it's still the same .NET project, but this time instead of breaking your head on YAML code, we're going to help you and offer you this graphical interface, which means that I'm going to start with integrating my NuGet package manager, since it's a .NET application, running NuGet restore to import all the packages in the build server, compiling my code using .NET build, running some tests, and eventually publishing and copying the files. So what it does here, if you're not really a developer, don't worry too much. So what it does is compiling my .NET source code and creating a web zip deploy package, similar to a manual approach in IIS long time ago, or even the web deploy integration out of Visual Studio, for example. Now from here, if I want to add tasks or remove them, I could say for now, I'm going to disable my testing, but I also want to integrate file copy. I can search for copy, and there we go. Copying files across Azure, running a robocopy script to run anything that might be relevant for your tasks, or integrating with Docker containers, for example, would also be an option here. And nice is that you don't really, again, need to become an expert on YAML files before you can start using it. So this is classic pipeline, and we're gonna run it again. Let's see how our previous task was doing. So in the meantime, it's running, and you can drill down and validate all the details. So from here, it started with initializing the job, nothing super fancy happening there. Validating and running the first task. So it's literally executing the manual steps like you would run them in the traditional approach where I started with in my presentation. And from here, it's literally going through all the details. Now to speed up the demo a little bit, I can show you what it looks like for a successful build, where it's walking you through each and every step. So up here, I can see that it's creating the folders. Don't worry too much about the orange warning lines. It's because the code I'm using is getting a little bit outdated. So it's about time to switch developer head and updating the code. But this is similar to the output you have in your development environment, like Visual Studio, Eclipse, or any other development tool. When all the rendering, the compilation is done, it's creating artifacts. And what it does here is creating a web snippet, where for now it's a 216, so it's some unique random name, and storing it again in my artifacts. Now, what is an artifact? It's the starting point for the release pipeline. So what is a release? It means that you're gonna grab the source code that you compiled and validated in the build stage, and now you're gonna move it to a running state. Now, why am I not telling you to run it in production? Because it's not limited to pushing something into a production scenario. So let me show you what this means. So you can start with defining a pipeline. And the nice thing is that it's all graphical as well. Now, nothing blocks you from combining build and release out of the YAML statements. But for now, I actually like the multi-stage concept in the graphical interface. So just one example, I was working on a web shop, where from here, I'm gonna run it on the Azure platform. So what I can do is, starting from my artifact, that's technically the build from the previous stage, and moving it to different environments, where for each and every stage, I can define like where do I wanna run my application. Again, this is based on a web app. So what it does is picking up the source code and deploying it in Azure. Where for here, I start with pre-creating my web app instance in Azure, but nothing blocks you from, for example, integrating Azure deployments. So if you already have an ARM template, you can inject the task, move it up, and integrating with your Azure subscription. Giving you a lot of different options and eventually allowing you to read out your resource groups, or if you want, you could also give it a more fixed name, new resource group. There we go. Running it in East US. And where can I find my template? It's back in Azure repos. So this is just browsing my folder and grabbing my template file. So this pipeline is going to kick off, and first of all, running the ARM template, Once the template deployment is done, it's going to pick up the source code and publishing the web application. Now, as you can see, it also gives you a nice overview where you can make some modifications for one specific release, like a running task, or for the pipeline itself. Now, I told you that we're really aiming to optimize it. So what we can do is running pre and post job conditions. For example, you can specify that instead of waiting till anyone is pushing the button and actually running the release and publishing it, you could move this to scheduled task. So imagine that as a developer or sysadmin, and I should say a DevOps engineer now, you could build your source code, you can check in the code and running a deployment like every night, 2 o'clock, and that's going to help you in optimizing. Or you could integrate pre-deployment approvals, where you're going to validate that your team lead, your developer, business team manager, is approving, validating the source code before it's okay, raising the green flag to publish the application source code or anything else. Or why not making it smarter from an Azure platform perspective? Imagine that I built my web app publish task here, like I showed you publishing to East US. But maybe out of my Azure environment, there's an Azure policy that's blocking me from deploying it in East US. So this scenario here is about similar to running a manual deployment, because Azure policy is going to validate the state of your subscriptions when you're touching on the resource providers. Where now with Azure DevOps, you could make it smarter. And as long as your source code definition or the pipeline definition is not in line with Azure policy statements, it's never going to run and not even going to try to publish. So that's going to help you as well. If you don't use Azure policies, but you want to validate the health state of the platform, you could use REST APIs, validating if like a resource is there before the pipeline kicks off, or if a resource is being removed, like it's not visible in the REST API lists anymore, that could be a trigger for redeploying it. Or integrating with Azure Monitor, like reading out App Insights alerts that once my web app CPU memory load is, for example, going through the roof, like 80-90% for longer than 5 to 10 minutes, before you could rely on Azure Intelligence, Azure auto-scaling feature, where now you could reuse the states of your alerts into managing your pipelines. Easy said, whenever demand comes in, it's going to trigger an alert, and based on the alert, we're going to run the deployment. Or maybe we're not going to run the deployment. What does it help you in publishing code to an Azure region web app when the web app instance is down? Or worst case, the whole region is down. That's not really going to help you, and that's what you can filter from here. But I'm quite sure I need another back to school session to actually cover all that in a next session. So that was build and release. So from there you push the button and it's starting publishing to the Azure platform, VMware platform on-prem, AWS, Google Cloud. The integration is there. Next to that, as I showed you, you can easily publish to different environments out of the same pipeline and building out dependencies, like what are the conditions under which I'm actually going to allow the pipeline to run. So really cool stuff, and too bad I don't have too much time to talk about all those cool features, but I'm going to talk to Dwayne and asking if I can please get some more media time and showing some other cool stuff. But with that, I'm going to close down for now. So we started with source control, optimizing your ARM templates, Terraform templates, PowerShell, or application source code relying on Git, thanks to Azure DevOps repos. From there, I talked about Azure boards, allowing you to use Kanban, integration, Agile, Scrum, project management. Move to pipelines, running the pre-flight validation, running a build, allowing you to optimize the deployment using the release pipelines, classic editor graphical interface, as well as the YAML, where again, for now, I cannot really immediately help you with any questions, but That's where I would like to thank you for being here, watching my session. I hope you enjoyed the rest of all the sessions we have here. Quite a lot of really cool content from our Azure friends. And with that, once more, thank you and hope to stay in touch. Feel free to shoot me an email, reach out on Twitter, or just follow me from my blog website. Thank you for now and enjoy the rest of your day.